Okay, continuing on with lesson 114. Now we're going to take a look at the zero factor theorem that you've heard before. The zero factor theorem is just when you have two or more products or two or more factors multiplied by each other and it equals zero, that you know that one of these must be equal to zero or both of them must be equal to zero. So we've used that to solve for equations before, where you've just set both of those factors equal to zero to be able to solve. We're going to use that same idea to find the zeros of the polynomials when we're graphing. So if we had something like this, x minus 4 times x plus 3 times x minus 15 is equal to 0, we know that if we let x equal 4, this would be equal to 0. Well, 0 times this is going to be equal to 0. And then the same thing with here. If x was equal to negative 3 or x was equal to 15, we see that those are the only numbers to the solution of the equation, because if x has any other values, the product wouldn't be equal to 0. So the zeros of a polynomial function are the values of x that cause f of x to equal 0. And the graph of the function is going to intersect the x-axis at those values. So if we look at this next part, oops, lost my thing. They have already factored this for us. If we had y equals x cubed minus 2x squared minus 5x plus 6, that could be rewritten as x plus 2 times x minus 1 times x minus 3. So it could be factored like that. We know that now that it's going to cross the x-axis at negative 2, so we can put a dot there. We know that it's going to cross the x-axis at 1, so we can put a dot here. And we know that it also is going to cross the x-axis at 3. So that kind of starts to give us at least some information about this graph. Now we're going to look back at what we talked about before. This dominant term here, if x was equal to a very large negative number, we know that this value then would be negative. So for very large negative numbers, as the x values become very large negatively, this is going to continue in a negative direction. If we had very large positive numbers, we know that that's going to continue in a positive direction. So we know that that part of the graph kind of looks like that. Now we need to kind of find a couple more points in here. I always think that 0 is a good one to pick, because if we put 0 in here and here and here, we're just going to end up with 6. So we know that when x is equal to 0, y is going to be equal to 6. So we have these points here. So now we need to kind of figure out, well, what is this going to look like? Because we know it's a cubic function, it's going to have at most 2 turning points. So we know that this is going to kind of turn somewhere in here and then somewhere down here. So we can just kind of pick, since this one's kind of condensed, we can pick a point here. So if this was negative 1, we'd have negative 1 cubed. Negative 1 minus negative 1 squared is just 1. So times 2 minus 5 times negative 1. So that's going to be plus 5 plus 6. So we have 11 minus 3 as 8. So we see that at negative 1, this is actually up just a little bit higher here. So the turning point is going to be, it might not be exactly at negative 1, but we do know that at least it continues there. So we've got that part. Now let's see at 2. What would we have? 2 cubed would be 8 minus 2 times 2 squared So that would also be 8 minus 10 plus 6. So what do we get here? So that's a 0, so we get negative 4. So at 2, that's at negative 4. So we have something like that. And that's how you could graph this cubic function. All right, let's take a look at example 114.1 now. So example 114.1. What do we have? We have graph f of x is equal to x times 1 minus x times x plus 1. Okay, so if we wanted to graph this, first let's look at what type of function is it. So because we have an x here, a negative x here, and an x here, we know that if we were to multiply this out, that's what the first term would look like. We would have a negative x cubed. So we kind of have that idea. This is the dominant term. So let's actually kind of start doing this here. Looking at this here, so we know that if we have very large negative values for x, that if you had a negative and you cubed it, it's going to be a negative, but then we have the negative out here. So opposite of a negative is going to be positive. So we know that for very large negative values, it's going to continue on in a positive direction. If we have very large positive x values, and you cube that, and then you have the negative sign in the front, you know that it's going to continue negatively in a lot of directions there. With the cubic function, again, remember that it could have one flex point, or it could have two turning points and a flex point. Here we can also look at the zeros, and x is equal to 0, or when x is equal to 0, it's going to cross the x-axis. Also at positive 1, and also at negative 1. So we have those points so far, and we could kind of see what's going on with the ends of the graph here. Now we want to just kind of get an idea of what's going to go on in here. So obviously this is going to be coming down. Something's going to happen here and here in order for that to then continue going in this direction. So we might want to take a look at like maybe 0.5, okay? So if we substituted 0.5 in there, we would have 0.5 times 1 minus 0.5, 0.5, and then 1 plus 0.5, 1.5. Okay, so 0.5 times 0.5, 125 times 1.5, okay, so we see at 0.5 that this is going to be equal to 0.375. So it's not going to go up very high. So I'm like, I don't know. I guess I didn't have it up very high before anyway. So that would be the graph, or the kind of a sketch of that polynomial function. All right, this next one, we're going to learn one more key factor in graphing these here. Example 114.2 says to graph this. What do we have? We have x plus 1, and then we have x minus 2 squared. Okay, and this is when you have a factor that's squared, this is what we're going to kind of learn something new about. So if we look at this, remember that this would be x times x, so that's next squared, and then times another x. So we know that we have x cubed. The sign in front of that would be positive because this is positive and both of those are positive. So we can kind of start thinking about the graph of that and what the ends of that would look like. So for very large negative numbers, this value would be negative, so it's going to be kind of going in that direction there. For very large positive values of x, it's going to be continuing up positively. We know that we have zeros at -1 and at 2, but this is what we're going to learn here, is that if you put any value in here for x and then you square it, this value will always be positive. So it never goes negatively at that point. So what happens when you have a factor that's squared is it's just going to bump the x-axis. It's not going to cross it. Okay, so we have that information. Let's see. Again, putting 0 in for x gives us a good point to do. So if we put 0 in here, we'd have 0 plus 1. It would be 1. If we put 0 in here, 0 minus 2, so -2, -2 squared would be 4. So when x is equal to 0, y is equal to 4. So that's another point that we have. And this is enough to at least sketch a graph for this. Okay, I know my graph doesn't look very good, but that's kind of the sketch of that graph. Okay, let's look at the next example. Example 114.4. It says, which of the following graphs most resembles g of x is equal to x, 3 minus x, x plus 2 squared. Okay, and we have, I guess draw all of these. We have this first one, and it goes through 0, and then through 3, and then this is -2, this is 3, the next one, it goes at -2, bumps up, and 3, so this is -2, and this is 3. The next one, we have it coming and bumping at -2, coming down, and crossing at 3, and then the last one bumps at -2, crosses at 0, and 3. So let's see here. All right, so which one would resemble, most closely resemble this? Let's take a look at this here. So we have an x, we have a negative x, and we have an x here. We have this negative x. This is squared, so that's x squared, x and x. So we're looking at a quartic function here. Because of this negative x, that lead term is going to look like that. So we know that it has to be opening down, which actually just with that, I think I'm already here, but let's look at some of the other stuff. So here x equals 0, oops, for c, yeah, it actually just crossed through 0, okay? So x is equal to 0, we have a 0 at 3, we have a 0 at -2. This is squared, so it's only going to bump. So just with that, c would most resemble this here. Let's now look at 114.1. Which of the following would most resemble this? H of x is equal to x minus 1 squared, x plus 1. Okay, so looking at this, without me even drawing out all of the other stuff, we see that this is going to be x times x times x, so we know that we have an x cubed. We know that the sign in front of the x is going to be positive. We know that we have the zeros at 1 and at -1. Because this is squared, we know that it's only going to bump at 1, and then it's going to cross at -1. So if we just look at those graphs, A, B, C, and D, we can see which ones can we cancel out. Let's see. A bumps at -1 and crosses at 1. Let me make sure I'm doing this right. Yeah. So that one, we can cross out A because it's bumping at the wrong place. B does bump at 1 and does cross at -1. So B is an option. C bumps at 1 and crosses at -1, so that's an option. D is out because it's bumping at both -1 and 1. So we're looking between B and C. So now let's take a look at this. So if our x values are very large negative values, so a very large negative, and then you cube it, is going to be negative. And then a very large positive value of x and you cube it is going to be positive. So we need the graph that for negative numbers goes negatively and for the positive numbers goes positively. So that would be graph B. And so that's the answer. I hope that helped it all tie together. Are we done? Yes. I hope that helped tie it all together. So again, you're looking at what is the graph looking like at the very far values of positive x values, positive y values. You tell that by that first term, that dominant term. You're looking for the zeros where it's going to cross the x-axis. And then just remember that if you have a factor and it's squared,